Think, please mute yourself. Okay. So, what is EDA is, Saib, you can start the recording. Okay. So EDA is the approach for analyzing data set. Okay. To summarize their main characteristics. Okay. Often with visualization or visual methods. Okay. So it goes beyond simply looking at raw data. Okay, whatever you have a raw data, you can convert that into a nice visuals with a nice visuals that will help you to take a decision making. Okay, it will also summarize data to see key statistics. Okay, visualize data to reveal the underlying patterns. Okay, generally in your data set you will see the patterns. Okay, even if you see the share market uh, chart right on BS index and all, you will see how it was doing yesterday. Okay, how it was doing last week. Okay, last month. Okay, so it gives you a decision making whether it is the right time to invest or stay out of it. Okay, and then ED also helps with cleaning data. Okay, by handling missing values and outliers. Okay, so there is a one separate session on missing values and outliers, why it is important. Okay, and then finally you can transform your data to prepare for the modeling, like if you want to do a probability, if it is a probability, you have a data set of a weather. Okay, last year. Okay, and with that data sets you have to predict whether next month whether it's gonna be heavy rain or moderate or mild, right? Or you can take 3 years statistics, okay, historical data, and then you can do the analysis. Okay, so this is a EDA 3 sheet I have created. So we will do all this summarization. I've already added in a notepad. So I'm going to add all these things as we go along. Sorry, list. Okay, so these are some of the points. You can say 1, 2, 3, 4. Okay, summarize data, visualize data to reveal patterns and relationship between two variables. Now, when we talk about variables, what are those? Column names. Okay, and then cleaning data by handling missing values and outliers and transforming data to prepare it for modeling. Further analysis you want to do. Okay, further analysis if you want to perform, you need to do the after the transformation. If there is no need for transformation, you can go with the modeling if your data is correct. Okay, so what we'll do is first I'll create a sample data. Okay, 1 minute. I have created in a notepad yesterday. Okay, if I type all those things, it will take a lot of time. Uh, minute. Okay, I got it. I just kept it in another document file. Okay, so I'll just paste it. Okay, and then I'll explain. Okay, so I am creating a data set sample. This is a sample. Okay, so this is a sample data set. Okay, I'm importing a pandas. Okay, pandas data frame. Sorry, pandas library, and I'm creating an instance of this library called PD, and then I'm creating a sample data. Okay, I'm mentioning this as data is equal to, and if you see curly braces, you have a key and values. Okay, now you see values, I've added 20. Okay, here age also randomly I've added something. Okay, and sex something. Okay, and marks and study hours. Okay, so I've created a sample data here. Okay, and I'm calling here df data frame variable empty is equals to pd. Okay, what is pd? Pandas dot data frame. Okay, so right now if you see, these are all linear data, right? Linear data. Okay, and if you want to convert this data into a data frame, which is like rows and columns, you have to use a data frame function, and you have to pass this variable called data wherever I'm storing all these things. Okay, so I'll run this. Okay, so no error. So I'll just run df dot info. Okay, let's see. Okay, so I have my data entry, 20 entries are there and 5 columns are there. Okay, so I have 5 columns. Okay, what are those columns? Name, age, sex, marks, and study hours. Okay, and all these are 20 rows. Okay, what that means is it's not empty. Okay, so nothing is empty. Okay, if I want to create a empty here, okay, in the initial stage, okay, so what I can do, I can say I can leave it like this. Okay, so I'll create again. Okay, and then where did I made empty? This is in sex. Okay, now you see there are 20. Now you will see a difference here. Okay, so you can see here it will not show, but when you run this one minute, I'll just add one two spaces. Okay, it has to be nan. Okay, it should come something like nan. Okay, but anyway, I'll take some sample data also. uh, I'll show you live. Okay, I'll just put it back whatever the data was there. Okay, so basic let's understand the basics here. Okay, 5 columns, and these are says this is non-null. Okay, and you can see on the right hand side, extreme right hand side, data type. What are the data types? Okay, if you see, the name is object categorical, age is integer. Okay, age is integer, and then sex object, and then we have marks which is integer, and study hours is in integer format. Okay, so these are first hands-on that we're gonna work on. Okay, and I'll also add all those commands here up front. Okay, so these are all the commands that we're gonna play around. Okay, so I'll just move this as markdown. Okay, or raw also I can do. Okay, so these are the commands that we have to practice. Okay, uh, it is not coming properly. Again, I have to format it. Okay, I don't want to spend time in formatting, so I'll just pick up raw and I'll just go through it. Okay, so first command is head. So what the head does, it shows the first 5 rows for this data. I'll say df dot head. Okay, so these are the first, and the index starts from 0. Okay, in Python, index starts from 0. Okay, what is the second command? Tail. Df dot tail. What tail does? It shows the last, it will display the last 5 rows. Okay, So you can see last 5 rows. Okay. Now you see the last index is 19. Okay. But we have 20 rows, right? So you have to calculate, you have to count this zero also because the indexing start from zero. Okay. So don't get confused. Okay. Next one is sample. Okay. So sample function, what it does is it picks up randomly 5 rows. Okay. Randomly from anywhere. Okay. It will not pick. See, right now the head and tail, if you see last 5 columns, last 5 rows and start 5 rows. Okay. But sample will give you random. Anything it will pick. Sample of, you have to mention the numbers or 10. Okay. Okay. Now you see this is the 13th row, 12th row, second, 17, 19, right? Okay. You see again sample I ran, it is picking up some other rows. Okay. So sample is also very useful when you want to inspect your data. Okay. Whether it is looking good or bad. Okay. So these are all the functions that you can make use of it. Next one is shape. Okay. Now what a shape does is it is not a function, it's an instance. Okay. Whenever you don't have a parenthesis here, open and close, we call it an instance. Okay. So what it shows is rows and columns. Okay. I'll just copy from here instead of typing. Okay. So it will save time. Okay. Now how many rows I have? First it will show row. So 20 rows and 5 columns. Okay. It's very simple. And columns. Okay. List of columns. Whatever the columns we have, all this it will show. Okay. And there's also instance. Okay. Okay. Now you see here. These are the name of your columns. Header. Name, age, sex, marks, and study hours. Okay. Uh, Then we have data type. What data type does? It will show you the type of data. Okay. Even with the info you can see here. Okay. So there is a separate option is available. You can use either info or this. Okay. You can see it just shows the column headers and their data type. Object, integer, integer. Okay. It is already there. Same thing. The last one. Okay. And info, what it does is it gives you the summary, data type and nulls. Okay. So we have already seen this info command here. Okay. Now describe, what it does is it summarizes your statistical and it will pick only numeric. Okay. Now if you see here, what are the numeric columns we have? Age, marks, and study hours. Okay. So by default, when you use describe method, which will give you the statistical imputation of your data, it will give you only the 3 columns: age, marks, and study. Okay. Now if you want to change the heading, okay, now you see the count, mean, this is the subheading. Okay. You want to make the um, heading with this I mean rows that you see here. Okay. You have to use transpose method dot t. Okay. Just dot t. Okay. Now you see count, mean, standard, minimum, 25, 50, 75 max. Okay. So same thing, whatever you see on the left, it is turned up and columns on the left. Okay. Now if you spend some time, if you see the count for each column is 20. Okay. Which is true. Okay. What is the average? Average is 22 years. Okay. Age. And what are the marks? Average is 80. Okay. And study hour on an average, what is the study hour people are spending, students? 13 hours. Okay. This is the average. This is the imputation. What is the standard deviation? 1.7. Okay. Difference from mean, all age group. You have 20 age group. If you count each one of them, okay. So there is a 1.7 deviation from the mean. What is your mean? 22. Okay. And what is the minimum age? 20 years. Okay. And what is the maximum? 26. Okay. And what is the 25th percentile bucket? Okay. What age groups falls under 25th percentile? 21 years of age, 50, 22, and 75, 23. Okay, so you can see the age group distribution here. Okay, understood, guys? Any doubt so far? No? Okay. And same thing with marks. Okay, marks
Please, Master.
20. Okay, and here you see the standard deviation. Okay, if you see all the marks from your mean, what is the difference each mark? Okay, 9.9. Okay, that is how it will derive. Okay, and you see what is the minimum marks? 65 is the minimum marks. Okay, and what is the hours they are spending? 8 hours. Okay, this is the analysis. Okay, 25th percentile, 71 marks age group. Sorry, marks. I mean, marks will fall under 25, and 82.5 will fall under this bucket. 50 and 75 will fall under 89. Okay, and maximum marks is 95. Okay, what is the hours they are spending? 19 hours. Okay, to score more, you have to spend more time on your learning. Okay, okay, and what is the other commands? Describe include is equal to object. Okay, this also I'll explain. Now here, whenever you have a data set, you can see you have a categorical data. These are all called object. Okay, okay, categorical. Okay, these are not non-numeric. Okay, now when you want categorical data also, you have to pass a parameter within this describe method, include equals object. Okay, now you see what happened here. So it is picking up only the object. Okay, and if you put a T here and then enter, you see the count unique top frequency. Okay, now you see name count is 20, unique is 20. Okay, so 20 unique entries are there. Okay, 20 unique entries are there. Who is a topper here? Amit. Okay, this person by the name Amit is a top and frequency is one time, it's not repeated. Okay, Amit is not repeated here if you see in the uh, initial data set that we created. Okay, so different name I picked up here. Okay, and if you see the six, okay, so total count is 20, unique is 2. Yes, why unique? You have male and female. Okay, which are unique? If you see the initial data set, you have male, female. Okay, so if I add something called trans, right? Okay, if I add trans, now you will see a difference. I'll just run all these things. Uh, okay, okay, now you see you have three now. Okay, earlier it was only two values. Okay, unique. So this is what it means, you have three. Okay, so when you have a list of something categorical in a categorical column, right, sometimes you get confused. Okay, what has to be done? Okay, in those cases what you will do is you will use this include is equal to object and you will get your summary of your data. Okay, okay, so I think, yeah, another way is you can also use, see if you want combination of categorical plus all numeric fields. Okay, so what you'll do is you'll say include is equal to all. Okay, now you see, now here you see five columns, one, two, three, four, five, all five columns, okay, which are categorical and numeric data. Okay, so what are my numeric data? Age, then I have marks and study hours. These are numeric. Okay, but if you see here, unique, nothing is unique here. Okay, and it says nan. Okay, so it doesn't understand those categorical data. It doesn't allow to compute standard deviation, minimum, max, and all that. So that is the reason it is showing as nan, not a number. Okay, for categorical data. Okay, for age also you can see. Sorry, age it is there, but name, you see Amit is a topper from this list. Okay, and now how do we write the inference? Okay, so after doing all this you have to write your inference. Okay, okay, I'll write this data set has 20 rows into 5 columns. Okay, age marks study as a numeric, sex is categorical, sex and name is categorical, and there is no missing value. Okay, so this is your first inference. After reading your data you have to add it here. Okay, I'll just add few more cells here. Okay, now what we'll do is we will play around with checking missing values. Okay, so checking missing values, what are the commands that we will use to check the missing values from the data? Okay, so these are the two commands. Okay, I'll just put it as raw and then I'll explain. Okay, one is null. Okay, you can use is null dot sum also. I'll show you the difference. Okay, uh, is null. Okay, sum. Okay, this also can do for duplicated. Okay, okay. So first we'll see whether we have any null value. Okay, so I'll say df dot is null and it's a function. Okay, you see everything says false. Okay, there is no missing value. Now here I have 20 rows. That is the reason you can see in a single tabular format. Okay, what if you have billions of records? Okay, you cannot see. Then you will use something called sum. Okay, sum will give you the clear picture whether you have any. Okay, it says 0, 0, 0, 0. Okay, this is what we have to use. Okay, when you have a less rows, okay, understood, you can use this. But when you have um, huge rows in your data set, like 1,000 rows or 2,000 rows or 10,000, right, you cannot go each and everything and read. Okay, so it says false. This is one way you can use it. Okay, and then you have duplicated. Okay, so we'll see all this one by one. So whether we have duplicated values, no. Okay, false, false, false. Okay, so all are false. Okay, so I can see this sum also here, sum. Okay, it will show beautifully for each and, okay, so it says 0. Okay, this way is 1 and this way also you can do. Okay, clear guys? Checking. Okay, now what is the inference that you can draw from this? Whatever the commands we have learned, you can say no missing value, no duplicate. Okay, so from your data set there is no missing value. This is how you have to write each and every step for your data. Okay, now we will do something called univariate analysis. What that means is single column analysis. Uni Okay, what that means is single column analysis. Okay, in columns you see columns, right, in Excel, right? Top header, okay, name, age, these are all called columns, right? So we are doing a analysis on single column. Okay, and if I want to do two columns, I will say bivariate. Okay, by stands for more than two. Okay, so what we have to do is we have to write the commands. Okay, now first thing first, I will add here columns df dot. Okay, I have these columns. Okay, now which column I want to do? First, I'll pick up age. Okay, so whenever you are giving a reference of your column name, it has to be square braces. Okay, square bracket. So inside quotation, I'll say age. Okay, it has to be lowercase, like you see here. Okay, if you mention a as capital, it will throw an error. Okay, now I want to count the values. So what I'll do, dot value count. Okay, this is a function I will use. Okay, so what it will do is it will show how many entries are there. Okay, now you see in the entire list 20 appeared 4 times, 21 marks appeared 4 times, 22 appeared 4 times, 23 sorry, age not marks guys, sorry. Okay, age group, if you see, 20 appeared 4 times in the entire data set where we have 20 entries. 21 4 times. You see, this is the analysis, clear analysis. You can do it for another numeric value, which is age. This is age, marks. Okay, marks definitely it will be there. Okay, so there is a tendency that two people can score 80, right? Okay, now you see every number is unique here, one time only. See, I've added those data just for understanding the sample data that I created, right? This is for understanding all your for your practice and understanding the data set for categorical and numeric data. Okay. So what is the other one? We have marks, age, and study hours. Okay, study hours also will do. Okay, so 12 hours, 2% were there who were studying 12 hours in a day. Okay, so 2% 15 hours, 19 2. Okay, only 1% 8 hours. So this is the analysis. So value count will give you the value for each column. Okay, how many times it was repeated. So this is where you have to inference your data. Okay, now we'll talk about analysis. Okay, univariate analysis using statistical imputation like mean, median, and all those things. Okay, I'll say df. Okay, marks I'll take. Marks, yes, marks. Okay, I want a minimum marks. Okay, what was the minimum marks in my data set? Okay, what is the minimum? I'll say min minimum and then this is the function I'll use. So 65 is the minimum marks from this data set. Okay, if I want to see the max, you will say same function except this function, you'll say max. 95 is the max marks. Okay, and what is the average for this field? I can say mean. Okay, means the function stands for average for this column only we are doing. Okay, so 80.75 for marks. Okay, same thing you can do for what is the average age. Age is 22. Okay, now let's see the median points. Okay, I'll just copy this instead of typing, it will save my time. Median, median. Okay, so 82.5 is my median. Okay, midpoint. Okay, and you can also use mode. Mode is repeated. Do you have any repeated value in marks? Okay, but see, mode. Okay, so these are all the numbers unique. Okay, nothing is repeated. If there is a repeated value, it will show repeated with the numbers. Okay, right now none. Okay, if I want to pick up the where is my data set? This one. Okay, study hours. Okay, describe only for this field. I'll say df. One minute. Study stu study hours dot describe method I will use only for one column. This is, see, we are doing univariate analysis for one column. You have to remember I am doing one column analysis. Whichever is numeric, I am doing that. Okay. So if I run this, you can see the count is 20, mean is 13, standard deviation is 3, minimum number is 8, hours. Okay, study hours minimum is 8, maximum is 19, and bucket. Okay, 25 percentile. What type of hours are coming? 10. Okay, 25% of the students are utilizing the 10 hours study time. Okay, in a college or in a hostel. Okay, 50 is 14 and the other one is 19. Okay, now let's play with categorical data. Okay, now what are the categorical data? I have name, then sex, and then yeah, name, sex. Yeah, these two. Okay, df name dot value count. Okay, so it will give one because this is not repeated. If something, see, you want to find out something is repeated or not, you can use the value count. Okay, right now this is 20, so okay, we can do that. But what if you have 100? I can say some function also here. Okay, so none. Okay, so if you don't like this one, you can use this one. Okay, so let's do the same for another categorical data, which is sex. Okay, now you see, male, there are 10 people in this entire data set, 20 data set. We have 10 people who are dominating, then female. Simple. And there is one trans, which I have edited later on. See, this is the analysis, guys. Okay, so you can do all these things. Okay, if you have a ticketing tool, right, you can do magic. with the ticketing tool. Okay, sorry, I mean to say the ticket data or HR analysis, how many users are coming. We have HR analysis also. Okay, I have a data set I'll pick up for those who are interesting. Okay, always work on multi-domain data set. Okay, don't stick to one, because since you are working in a support function, just don't use the support function. Okay, if you work in different domains, okay, like marketing, campaign, okay, or some analysis, okay, uh, uh, training analysis, okay, and after training, what is the user or employee throughput, okay, after the training is done. Okay, so you can pick all those data points and you can do the analysis. Very beautiful analysis you can do. Okay, so these are all categorical columns. Okay, these two, name and okay, you can use this value count not only for numeric, you can use it for categorical. That is what I want to show you guys. Okay, this is one column analysis. Okay, and we have one more command that I want to show you is you have value count, right? In value counts you have something called normalize. Okay, so I'll show you one of the examples of transforming your data. Okay, transformation is one of the phase in your entire EDA journey. Okay, so I'll say what is that? NOR, yeah, normalize equals, I think, true. Okay, yeah, true. And I want to multiply this with 100. Okay, that is percentage. I'll just put here hash percentages. Okay, okay. Now you see what I did simple is I use the normalize. Okay, the same data that you see 10, 9, 1. Okay, so what I'm doing is I am doing a normalize here, okay, with 100%. Okay, so male is 50%, okay, female is 45% in the entire data set, and trans is 5%. Okay, this is how you can transform your data. Okay, this is called the transformation. Okay, not just show how many counts and all. No, you have to transform your data, understand your data set first. What are the things that you want to do with your data set? Jot it down on a piece of paper, and then you have to follow step by steps to come out of the analysis. Okay, now I'll draw the inference now. Okay, so what is my inference here? Okay, well, first one is ages mostly between 20 to 26. True. Marks between 65 to 95. We know 65 is the min and max is 95. Average is equal to 81 marks. Okay, study hours range from minimum is 8 to 19. Average is 13 hours per week. Gender is evenly split, and 10 male, uh, 10 male, 9 female. Okay, and 1 trans. Okay, so this is the inference that you have to draw. Okay, so after you do data set, keep a habit of writing your inferences. Okay, what your data is talking about. Okay, out of the data set 20 rows, 50% I see a male dominating here and female with 45%, and rest one is 5%, which is one trans out of the entire data set 100%. Okay, this is how you have to write it here. Clear, guys?
Yes.
Okay. Now, what is the time? We have 10 minutes. Okay. I'll do bivariate analysis. H- T- Okay. Bivariate means I'll explain. So what does bivariate means? Two columns. Okay. Earlier we did only one column analysis. Now two columns. Okay. We'll pick the same data set. Okay. Now what we'll do is the analysis between age and marks. Okay. First we'll spend some time to understand. Age versus marks. Okay. Now I'll find out some analysis in front of you. Okay. So I'll say DF. Okay. And what I want to do, DF uh, age. 1 minute. I have to add one more here. Okay. When you are doing a two analysis, you have to add one more square braces. Okay. It comes by practice only, guys. Okay. So I'll type age, comma, marks. It is called marks only, right? You can go back here. Yeah, MARKS, marks. Okay. Okay. So this is their data, dummy data. Okay. So I'm picking up these two columns. Okay. Now I'll copy this command. Okay. I can see mean. Okay. What is the mean between these two, age and marks? Okay. So age is 22, marks is 80. Okay. That is my first analysis. Okay. I can use something called group by. In Excel, sorry, yeah, in Excel, I don't know, I never worked on Excel. Okay. I have limited knowledge in Excel, but group by everybody knows, right? Here in this forum. So I'll use group by df dot group by. Yeah, this is a function I'm going to use. When I say function, it will have a close and open braces. Here, with what I want to do. Okay, so any categorical data you can pick up from our data set. Okay, I'll pick up X. Okay, and then I'll pick up the numeric data, which is marks. Okay, I'll run this first. Let's see. Okay, sorry, I have to use this is a series, so I have to use mean. Okay, average function. Okay, now you see, so I'm doing a group by. Okay, 89%. Okay, so score, if you see, what the topper here, this trans, and then followed by female, 89%, and followed by male. Okay, this analysis with one command you are able to achieve. Okay, so this is one. Uh, Agent marks we can do for, I'll just copy this here slightly. Instead of this, I'll say age. Okay, age and marks. Okay, what age group you see here who are excelling in marks? Okay, 20. So 20 age group are with a mean of 88%, and as the age goes up, you can see the marks are going down. So youngsters are scoring here more. Okay, this is analysis. Okay, same thing you can do for study hours also. Okay, so I'll just stu steady, not this one. Stu steady underscore. Okay, so you can see who is spending more time, this community. Okay, 19 hours. Okay, male just 10 hours on an average. Okay, and topper is sorry, topper is female, second topper is females. Okay, so they're spending almost like 16 hours. So average I'm taking here. Understood, guys? Yes, no.
Yes.
Is it interesting? Is it interesting or going above your head? Okay. So I'll put all these things under raw. Okay. So this is the, see, inferences I have written here. Okay. So older students 25 to 26 have slightly lower marks than younger ones. This is the inference you have to draw from this one. Females average 89 scored lighter, higher than males, average 74 to 78. Okay. And then female students also studied more hours than on average. Okay, so this data I have changed, guys. If you remember, trans I have added here. Okay, to just to show the content, I'll just change it back. Okay, so you don't need to run all these things. You can go last and this here, right? Yeah, here. So trans is there, right? So I'll run this first. Okay, now you will not see trans because I have changed it now. Okay, so this is just for your reference. I was adding that value there. Okay, now this is good. Okay, 17% females are uh, spending. Okay, 17 hours on an average mean. Okay, same thing if you add mode, median, and all, you can try all these things. Okay, clear, guys? Any doubt so far? Okay, so I'm gonna share this now. Okay, these are all for your practice. Clear output for all cells. Okay, I have cleared all the output. So when I share, I'll share something like this. Okay, so you have to just click on, okay, just run this, run this, run this. Okay, and then all the results you can see. Something like this. Okay, these are all the commands that we learned. Okay, so tomorrow what we will learn is correlation analysis, outlier detection, okay, and then feature engineering, okay, with these data R's, okay, how we can do a transformation, okay, from the existing data, okay, and then we will also learn about sorting and filtering. Okay, we have a lot of things, okay. So I'm just teaching just 1% or 2% of the entire EDA. Okay, so these are all one-line commands that we are learning here. Okay, so let me share it. You can stop the recording type. I'll share the sheet. These are all very important sheet, guys. Okay, so if you take all these commands,